Hey physics people, so we're going to do a quick video on this question here. It is a paragraph length response FRQ, and here's how it goes. Alright, so if you look at this, I can read through this and remember to read carefully. It says that this team drops the block from this height and it launches off of a table at this height. This team launches from this height or releases from this height, and it goes down, and it says that the team wants to end up going the same distance, so they made a little upslope, so it launches off from H because they think that it will go the same distance. All right, now we're going to justify this. All right, do block 1 and block 2 land the same distance from the respective table? And the answer is no, they do not. Okay, we're going to justify our answer, and this can be really simple. The reason is because team 1, so both sides, however, team 2's table is lower than table 1. Okay, so team 1 started with more potential energy, which means it would have more kinetic at the bottom, but I'm just going to simplify this and say, which means it is traveling with a greater velocity, with a greater v. When it leaves, okay, so if it has a greater velocity when it leaves, but it takes the same time to drop from H. So that if this height is the same, it takes the same time. And the way that we could explain that is through the kinematic equation. And we don't have to write this down here. If you just say that it takes the same time, then we're good. But just as a quick reminder, here is the equation we would use, the modified kinematic equation. So for dropping off of H, its velocity in the y direction starts off with 0, so I can cancel that out. And you can see that t is equal to, and it's going down, so technically that's a negative delta y. So t is equal to the square root of 2 delta y over g. It's the same time for both of those. So since it takes the same time to drop H, and v equals delta x over t, delta x1 is greater. All right. Now, so again, like the whole basis of this is that it has more energy. So this one's going to be moving faster than this one. So it takes the same time for both of these to drop the same height. But since this one is moving faster, it's going to go a further distance. Okay. So let's get the big eraser out here. All right, so erase all this. Okay, that was number 1. And remember, really just go through and you can almost bullet point pieces here, because if you didn't get all of that, then you can still get some points. Okay, so now we have both blocks are released from, now we have in another experiment, teams 1 and 2 use tables, no friction. However, the two slides have different shapes as below. Both blocks are released. Which block, if either, lands farther from the respective table? Okay, in this case, the two blocks go at the same. And again, that's because they both, team 1, team 2, have the same energy. So energy initial is equal to energy initial here. So both have the same energy. And so they both have the same velocity. So team 1, so velocity, let's say velocity 1 right here. So this velocity is equal to this velocity of 2 right here. And you would have to verbally describe this. But I'm just going through the key points here. And then the heights are the same. Height 1 is equal to height 2. And so the times are the same. T1 is equal to T2. Both of these times for it to fall. And again, like you're going to have to elaborate that this is the time for it to fall. This is the time for this one to fall. So all these are the same. And if V equals delta X over T, T equals, delta X equals VT. So if V and T are the same, delta X's are the same. They both travel the same distance. All right, there's an explanation for that one. And again, you're just going to have to write that in a paragraph length response. So just hitting all those key parts. All right, now this one's a little bit trickier. It says which block hits the floor first. So which one do you think hit the floor first? All right. The first, at first glance, you might think that, oh, it's going to take the same time because they have the same energy and they have the same velocity here. But the thing that's different is which one of these hits that velocity sooner. And you can see that block 1 hits this velocity sooner. So there we could say that the acceleration for team 1 is greater than the acceleration for team 2. All right. And there's multiple ways you can explain that. One is you would have the average, the normal force here from the surface pushing on the block is less than the normal forces here, like that. You're gonna have, there's more normal force here. So the surface is pushing has more normal force overall. So as the surface is pushing up against it, so therefore these accelerations are different. Another way to see it is that since if you were to straighten this out, you could say that that the distance of the slide, or the length of the slide, is greater for team 2. And so if it takes a greater amount of time for it to go, or if it's a greater distance, then it's going to take a longer time for it to accelerate. So down here, they both hit V, but this one has less of an acceleration. You can say because it has a longer distance, or because there's more normal force counteracting the gravitational force. This one is, this acceleration is closer to G, which it would be G10 if it was just in free fall. Okay, so I think that's everything. Yeah, okay, all right. Hope this helped.